Hello viewers, welcome to our channel Career Prep. In this video, we'll learn about the different types of questions on calendars that can be asked in competitive exams. Calendars is one of the most important topics for government sector entrance exams like UPSC, SBI PO and Clerk, IBPS PO and Clerk, RRB PO and Clerk, SSC, etc. Questions which come from this section are usually very easy to solve if you know the key concepts. Before we begin, please subscribe to our channel. Also press the bell icon to get notifications as soon as we post a new video. So let's start. The questions on calendars can be broadly categorized into the following types: counting odd days, with reference date, without reference date, repetition. Let's learn in detail about these types. Let's now learn about question type 1, counting odd days. In this type of calendar reasoning questions, you are asked to find the number of days, weeks, months, etc. Odd days means those extra days which cannot make a complete week. To find the number of odd days, you need to divide the given number by 7 until a remainder is obtained which is less than 7. You have to know that you're dividing by 7 because 7 days make a complete week. Now let's look at an example to understand how to solve type 1 questions. How many odd days are there in 1000 years? Now you should know that from 500 years onwards, you have to first subtract the given year with the nearest century leap year. Then find the number of odd days for that answer. Now for 1000 years, 800 is the nearest century leap year. So 1000 minus 800 is 200 years. We know that for 100 years, there are 5 odd days. So for 200 years, there will be 5 multiplied by 2, that is 10 odd days. Now 10 divided by 7 leaves a remainder of 3, which means there are 3 odd days. So there are 3 odd days in 1000 years. Now it will be easier and faster to find the number of odd days if you remember that 100 years has 5 odd days, 200 years has 3 odd days, 300 years has 1 odd day, and 400 years has 0 odd days. Let's now look at question type 2 with reference date. In this type of calendar reasoning questions, you'll be given a day for a particular date, and based on that, you need to find the day of the given date. Let's learn how to solve type 2 questions with the help of a few examples. If today is Monday, what day will it be 128 days after today? First, you have to find the number of odd days. So 128 divided by 7 leaves a remainder of 2, which means there are 2 odd days. Now it's given that today is Monday. So Monday plus 2 is Wednesday. So 128 days after today, it will be Wednesday. If March 1st, 2024 is a Saturday, what day of the week will it be on September 1st, 2024? Now here it's given that March 1st, 2024 is a Saturday, and you have to find out which day it will be on September 1st, 2024. To do that, first you have to find the number of odd days. For that, first count the number of days between March 1st, 2024 and September 1st, 2024. Now, since you are starting from March 1st, 2024, you have to consider all the 31 days in March. And since in September you have to count till September 1st, it means you have to you have to consider only one day in September. So the total number of days between March 1st, 2024 and September 1st, 2024 would be 31 days of March plus 30 days of April plus 31 days of May plus 30 days of June plus 31 days of July plus 31 days of August plus 1 day of September. When you add all this, you will get the total number of days as 185. Now find the number of odd days for 185 days. So 185 divided by 7 leaves a remainder of 3, which means that there are 3 odd days. Now it's given that March 1st, 2024 is a Saturday. So Saturday plus 3 is equal to Tuesday. So September 1st, 2024 is a Tuesday. Let's now look at question type 3 without reference date. In this type of calendar reasoning questions, you'll be given a date and you need to find the day of the given date. Let's learn how to solve type 3 questions with the help of an example. What was the day on 26 January 1950? When you look at this question, you'll clearly see that you have not been given any other reference date. You're just asked to find the day on 26 January 1950. Now the date 26 January 1950 can be divided as follows for easy calculation. 26 January 1950 has 1949 complete years, and in 1950 there is the period from 1/1/1950 to 26/1/1950. So 26 January 1950 can be divided as 1949 years plus period from 1/1/1950 to 26/1/1950. Now we can split 1949 years as 1600 plus 300 plus 49. Let's find the number of odd days for these three. Then let's find the number of odd days for the period from 1/1/1950 to 26/1/1950. So now we have split 1949 years as 1600 plus 300 plus 49. First, let's find out the number of odd days in 1600 years. Now 1600 is a multiple of 400 years. We know that 400 years has 0 odd days. Hence 1600 years also has 0 odd days. Next, let's find out the number of odd days in 300 years. Now we know that 300 years has 1 odd day. Next, let's find out the number of odd days in 49 years. Now to find the number of odd days in 49 years, first we have to know how many leap years and how many ordinary years are there in 49 years. To do that, we have to divide 49 by 4. The quotient will give you the number of leap years in 49 years. So when you divide 49 by 4, you get the quotient as 12, which means there are 12 leap years in 49 years, and the remaining years are the ordinary years. So 49 years has 12 leap years plus 37 ordinary years. Now we know that one leap year has 2 odd days. So 12 leap years would have 12 multiplied by 2 odd days. We know that one ordinary year has 1 odd day. So 37 ordinary years would have 37 multiplied by 1 odd days. So number of odd days in 49 years would be 12 multiplied by 2 plus 37 multiplied by 1, which is 61. Now 61 divided by 7 leaves a remainder of 5, which means there are 5 odd days in 49 years. Now let's find the number of odd days for the period from 1/1/1950 to 26/1/1950. Now January 1st to January 26th of 1950 has 26 days. So we have to calculate the number of odd days for 26 days. 26 divided by 7 leaves a remainder of 5, which means there are 5 odd days in the period from 1/1/1950 to 26/1/1950. So total number of odd days is 0 plus 1, which is 1, plus 5, which is 6, plus 5 is 11. So total number of odd days is 11. 11 divided by 7 leaves a remainder of 4, which means there are 4 odd days. Now 4 means Thursday. So 26th January 1950 was a Thursday. Hope you have understood how to uh, find the day of the given date when no reference date is given. Now we can also find the day of the given date when no reference date is given using a shortcut method. So let's learn about the shortcut method now. Let's now learn about the shortcut technique to find the day of the week for a given date when no reference date is given. Now to use the shortcut technique, you have to memorize the month code and the century code. The month code is 033-614-625-035. The century code is 6420. Now, unless you memorize the month code and the century code, you won't be able to use the shortcut technique. So first memorize these two codes. Now let's understand what the month code and the century code mean. Now first look at the month code 033-614-625-035. Here each number corresponds to the particular month of a year. For example, the first number in the month code is 0. So 0 is the code for the first month of the year, which is January. The second number in the month code is 3. So 3 is the code for the second month of the year, which is February. 3 is the third number in the month code. So 3 is the code for the third month of the year, which is March. 6 is the fourth number in the month code. So 6 is the code for the fourth month of the year, which is April, and so on. So 1 is the code for May. The code for June is 4. For July it is 6. For August it is 2. For September it is 5. For October it is 0. For November it is 3. And for December the code is 5. So each number of the month code corresponds to a particular month of the year. Now let's look at the century code. The century code is 6420. Now starting with the century leap year, consider every 400 years as a set. If the given year falls in the first 100 years, then the century code is 6. If the given year falls in the second 100 years, then century code is 4. If the given year falls in the third 100 years, then century code is 2. If the given year falls in the fourth 100 years, then century code is 0. The century code 6420 repeats for every set of 400 years starting with a century leap year. Now let's understand this with the help of an example. Now let's consider the year 1600. 1600 is a century leap year. So let's start this set of 400 years from 1600, which is a century leap year. So 1600 to 1699 is the first 100 years. If any year falls between 1600 to 1699, then the century code is 6. Next is 1700 to 1799. 1700 to 1799 is the second 100 years. If any year falls between 1700 and 1799, then the century code is 4. The next 100 years is 1800 to 1899. So 1800 to 1899 is the third 100 years. If any year falls between 1800 and 1899, then the century code is 2. The next 100 years is 1900 to 1999. So 1900 to 1999 is the fourth 100 years of the set. If any year falls between 1900 and 1999, then the century code is 0. The next set of 400 years will start with 2000, since 2000 is a century leap year. So 2000 to 2099 is the first 100 years of the next 400 years set. If any year falls between 2000 and 2099, then the century code for that year is 6. The next 100 years is 2100 to 2199. So 2100 to 2199 is the second 100 years of this set. If any year falls between 2100 to 2199, then the century code for that year is 4, and so on. As you can see here, the century code 6420 repeats for every set of 400 years. Now remember these two century codes, because most of the questions asked in competitive exams fall between these two uh, uh, centuries. So 1900 to 1999 is the fourth 100 year. Any year falling between 1900 to 1999 will have a century code as 0. 2000 to 2099 is the first 100 years, and any year falling between 2000 and 2099 would have a century code as 6. Hope you have understood the meaning of the month code and century code. First, memorize both these codes properly. Now, once you have memorized the month code and the century code, it's easy to find the day of the week for the given date using the shortcut technique. So let's learn how to find the day of the given date using these codes. With the help of an example, let's now learn how to use the shortcut method to find the day of the week for the given date where no other reference date is given. So look at this example. What was the day on 26 January 1950? As you can see here, you're asked to find the day on 26 January 1950, but you're not given any other reference date. Now, to solve this question using the shortcut technique, you have to remember the month code and the century code. So month code is 033-614-625-035 and century code is 6420. Now let's find out what day was 26 January 1950 using the shortcut method. In the shortcut method, first step is to find the last two digits of the given year. Here the given year is 1950. The last two digits of this year is 50. So the last two digits of the given year is 50. The next step is to divide 50 by 4. Quotient is 12. Next is to write down the given date. Here the given date is 26. So the date is 26. The next step is to write the month code for the given month. So here the given month is January. From the month code, we know that the code for January is 0. So the month code is 0. Next is to write the year code for the given year. So here the given year is 1950. Now as you know, the year 1950 falls between 1900 and 1999, which is the fourth 100 years of the set. So using the century code, you know that the code for the fourth 100 years of the set is 0. So the code for 1950 is 0. Now add all these numbers. So 50 plus 12 plus 26 plus 0 plus 0 is 88. Now find the number of odd days for 88 by dividing by 7. So 88 divided by 7 leaves a remainder of 4, which means there are 4 odd days. Now we know that 4 means Thursday. So 26 January 1950 was a Thursday. Let's look at question type 4, repetition. In this type of calendar reasoning questions, you will be given a year or month, and based on that, you need to find the year or month which will have the same calendar as the given year or month. Now for 2 years to have the same calendar, they have to satisfy two conditions. The first condition is the first January of both the years should fall on the same day. That is, sum of odd days between the 2 years is 0. The second condition is both the years are of the same type. That is, either both the years are leap years or both the years are ordinary years. Only then they'll have the same calendar. Let's now learn how to answer type 4 question, which is repetition of calendar year with the help of an example. Now look at this example. Which year will have the same calendar year as the year 2001? Now to calculate the repeat year, the sum of odd days between the 2 years should be 0. That is, the sum of odd days must be divisible by 5. Also, both the given year and the repeat year must be of the same type. That is, either both should be ordinary years or both should be leap years. Now here, since the given year is 2001 and since 2001 is an ordinary year, both 2001 and the repeat year must be ordinary years. So the first thing here is to uh, count the number of odd days starting from the given year 2001 till we get a sum of odd days which is divisible by 7. So let's start with the year 2001. Now 2001 is an ordinary year, so one odd day. 2002 is an ordinary year, so one odd day. 2003 is an ordinary year, so one odd day. 2004 is a leap year, so two odd days. 2005 is an ordinary year, so one odd day. 2006 is an ordinary year, so one odd day. Now, as you can see here, the sum of odd days at the end of the year 2006 is 7. So, now 7 divided by 7 leaves a remainder of 0, which means there are 0 odd days at the end of 2006. So, the next year 2007 can have the same calendar as 2001. Also observe that 2007 is an ordinary year just like the given year 2001. So 2007 will have the same calendar as 2001. Let's now look at another example in repetition of calendar years. So look at this example. Which year will have the same calendar year as the year 2002? Now to calculate the repeat year, the sum of odd days between the 2 years should be 0. That is, the sum of odd days must be divisible by 7. Also, both the given year and the repeat year should be of the same type. That is, both are either leap years or both are ordinary years. Now here since the given year 2002 is an ordinary year, the repeat year must also be an ordinary year. Now the first thing to do here is to count the number of odd days starting from the given year 2002 till we get a sum of odd days which is divisible by 7. So let's start with the given year 2002. Now 2002 is an ordinary year, so one odd day. 2003 is an ordinary year, so one odd day. 2004 is a leap year, so two odd days. 2005 is an ordinary year, so one odd day. 2006 is an ordinary year, so one odd day. 2007 is an ordinary year, so one odd day. Now, as you can see here, the sum of odd days at the end of the year 2007 is 7. Now, 7 divided by 7 leaves a remainder of 0, which means there are 0 odd days at the end of 2007. So, the next year, which is 2008, can have the same calendar as 2002. But observe here that 2008 is a leap year, whereas 2002 is a ordinary year. So clearly 2008 cannot be the repeat year. So let's continue with counting the odd days. So here 2008 is a leap year, so two odd days. 2009 is a ordinary year, so one odd day. 2010 is an ordinary year, so one odd day. 2011 is an ordinary year, so one odd day. 2012 is a leap year, so two odd days. Now, as you can see, the sum of odd days at the end of the year 2012 is 14, which is clearly divisible by 7. Now 14 divided by 7 leaves a remainder of 0, which means there are 0 odd days at the end of the year 2012. So the next year 2013 can have the same calendar as the given year 2002. Also observe here that 2013 is an ordinary year just like the given year 2002. So 2013 will have the same calendar as 2002. Now you can answer type 4 questions, which is repetition of calendar year, by shortcut method also. But you have to remember the rules to find the year which has the same calendar as the given year. Now the rules to find the year which has the same calendar as the given year are different for leap year and ordinary year. So let's now look at the rules if the given year is a leap year. Now rule number 1 is the given year and the repeat year should both be leap years. Rule number 2, leap year calendar repeats after 28 years. Now let's understand this with the help of an example. Which year will have the same calendar year as the year 2012? So as you can see here, the given year 2012 is a leap year. So you have to add 28 to 2012 to get the repeat year. So 2012 plus 28 is 2040. Now as you can see here, 2040 is a leap year. So both 2012 and 2040 are leap years. So 2040 will have the same calendar as the given year 2012. Rule number 3. Now after adding 28 to the given leap year, if you do not get a leap year as the answer, then instead of 28, add 40 to the given leap year to get the repeat calendar year. Let's understand this rule with the help of an example. Which year will have the same calendar year as the year 1872? As you can see here, 1872 is a leap year. So let's add 28 to the given year. So 1872 plus 28 is 1900. Now 1900 is a century year which is not divisible by 400. This means that 1900 is not a leap year. Now since 1900 is not a leap year, instead of adding 28, we have to add 40 to the given year 1872. So 1872 plus 40 gives us 1912, and as you can see 1912 is a leap year. So both the given year 1872 and the year 1912 are leap years. So 1912 will have the same calendar as the given year 1872. Let's now look at the shortcut method to find the years which have the same calendars when the given year is a ordinary year. So when the given year is an ordinary year, if the immediate year previous to the given year is a leap year, then the next repeated calendar year would be given year plus 6. Let's understand this with the help of an example. Supposing the given year is 2001. Clearly 2001 is an ordinary year. The immediate year previous to 2001 is 2000. Now 2000 is a leap year. So the next repeated calendar year is 2001 plus 6, which is 2007. So the calendar of the year 2001 repeats in the year 2007. Now if the immediate year previous to the given year is an ordinary year, then the next repeated calendar year is given by given year plus 11. Let's understand this with the help of an example. So the given year is 2002, which is an ordinary year. Now the year immediate previous to 2002 is 2001, which is also an ordinary year. So the next repeated calendar would be 2002 plus 11, which is 2013. So the calendar of 2002 repeats in the year 2013. So for the shortcut method, just remember that if the given year is an ordinary year, then look at the immediate year previous to the given year. If the immediate year previous to the given year is a leap year, then the repeated calendar year would be given year plus 6. If the immediate year previous to the given year is an ordinary year, then the next repeated calendar year would be given year plus 11. Now, there are exceptions for this rule. So let's now look at the exceptions of the rule. So now that you know the shortcut method and the rules for finding the calendar repeat years when the given year is a leap year or when the given year is an ordinary year, let's look at the exception for calendar repeat years. So there is an exception for the shortcut method for finding calendar repeat years. Now the exception is if the given year is in the 90s and the year ends in a century ordinary year, then the order of repetition would be 12 12 12 6 6 6 12 12 12 6. The order of repetition is from the year 90 to 99. This means if the given year is 90, then you have to add 12 to get the repeat year. If the given year is 91, then you have to add 12 to the given year to get the repeat year. Similarly, if the given year is 93, then you have to add 6 to the given year to get the repeat year, and so on till 99, which means if the given year is 99, then you have to add 6 to the given year to get the repeat year. So the order of repetition is 12 12 12 6 6 6 12 12 12 6, and the order of repetition is from the year 90 to 99. Now let's understand this with the help of examples. Look at this example. Which year will have the same calendar year as the year 1892? Now, as you can see here, the year 1892 ends in 1900, which is a century ordinary year, because 1900 is not divisible by 400. Now, the given year is 92. So, as per the order of repetition, uh, for the given year 92, you have to add 12 to get the repeat year. So 1892 plus 12 is 1904. Now the given year 1892 and 1904 are leap years. So calendar of the year 1892 repeats in 1904. Let's now look at another example. Which year will have the same calendar year as the year 1799? Now, as you can see, the year 1799 ends in 1800, which is a century ordinary year, because 1800 is not divisible by 400. Now, the given year is 99. Now, as per the order of repetition for the year 99, you have to add 6 to get the repeat year. So, as per the order of repetition, 1799 plus 6 would be 1805. Now, both the given year 1799 and 1805 are ordinary years. So, calendar of the year 1799 repeats in 1805. So, here is a quick recap of the shortcut rules and the shortcut exception for calendar repeat years. First, let's look at the shortcut rules for calendar repeat years. The given year and the repeat year must be of the same type. That is, both must be leap years or both must be ordinary years. Now, if the given year is a leap year, then the rules are the leap year calendar repeats after 28 years. After adding 28 to the given leap year, if you do not get a, a leap year as the answer, then instead of 28, add 40 to the given leap year to get the repeat calendar year. Now let's look at the rules when the given year is an ordinary year. Now, when the given year is an ordinary year, you have to look at the year immediately previous to the given year. If the immediate year previous to the given year is a leap year, then the next repeated calendar year is given year plus 6. If the immediate year previous to the given year is an ordinary year, then the next repeated calendar year is given year plus 11. Let's now look at the shortcut exception for calendar repeat years. If the given year is in the 90s and the year ends in a century ordinary year, then the order of repetition would be 12 12 12 6 6 6 12 12 12 6. This order of repetition is for the years from starting from 90 to 99. Please remember these shortcut rules and shortcut exception, which will make solving of problems in repetition of calendar years very easy. Viewers, please go through this video till you have understood the concept. A thorough knowledge of the concept will help you in answering questions correctly on this topic. Also, please do watch our video on calendars, basics, solved problems for more clarity of the concept. If you have liked this video, please like, subscribe and share this video. Thank you.